Going to problem 2 for this practice exam. So the dominant frequency of a jackhammer using discrete Fourier transforms. So we're given a following signal, and we can kind of see this kind of jackhammer hitting here and the force that's measured. So we can see the difference between here and here. We have a delta t equal to 0.0001 seconds. I'm going to actually go ahead and start doing some calculations here. So my delta t equals, let me make sure here, 0.0001. Let's make sure 1, 2, 3 zeros. Fantastic. That's my delta t. I know that my f sub s is equal to 1 over delta t. Let's go ahead and get that guy running. Mathematica is thinking. My computer has been running slow, and fantastic. I know that my f Nyquist is equal to f sub s divided by 2. And I think I can, that's where I have to stop. Okay, now let's look at the signal and see if it's periodic or if it's not. So minus 6, that's 1, 26, 2, minus 42, 3, 23 is 4, 40 is 5, 27 is 6, 36 is my 7th point, and then 5 is my 8th point, and then, oh, it repeats after that. So my total number of points, my big N equals 8. Let's just make sure again. 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. So let's go over here. So now I could do my period. Big T equals big N times delta T. And then my delta F is equal to 1 divided by T. Excellent. I should know that my big N divided by 2 times my delta F should be equal to my F Nyquist. So that looks right there. Excellent. I think that's pretty much all we need, or what we can kind of deduce from kind of this information. So let's go ahead and see what that question is asking. All right, calculate the period, which is t. So I got that. Sampling frequency. We got n. We got delta t. We got delta f. We got Nyquist. Again, I've solved this problem just by looking at this information and kind of writing down all my kind of parameters here. So even if the question didn't ask this, which it will ask you that on the exam, be sure to kind of just write these out anyways. It gives a nice kind of partial credit point. We also need to figure out what's my lowest frequency. That's going to be my delta f. What's my maximum frequency? That is going to be my n over 2 delta f, which is going to be my f Nyquist. So I've already answered those questions without having to figure it out. But in order to get my dominant frequency, I know that I'm going to have to plot that my frequency spectrum. And my number of harmonics is going to go from 1 to n over 2, which is going to be 4 harmonics. So let's count out, and actually let's get our harmonics. So here I'm going to have to do some data. So my data equal to minus 6, 26, minus 42, 23, minus 40, minus 27, minus 36. Let me just make sure this is correct. So let's go from here. Minus 6, 26, minus 42, 23, minus 40, minus 27, minus 36, 5, and repeats. Excellent. So that's going to be my data. So I know I'm going to have to do basically a table where I'm going to take my data as a function of r delta t. We could actually go back and look at, let's look at our lecture 7 notes, although we shouldn't need to use this on the exam. Have this ready to go. Times cosine 2 times pi times r times n divided by my big N. Excellent. And I'm going to go from r, actually I already have my table there. I'm going to go from r from 1 to my big N value. Oops, close that. And then I need to do the summation, which is going to be this. So total, right here. And that's going to be, I'll multiply this whole thing by 2 divided by my big N. And that's going to be my A sub n. And I'm just going to do right now, my A sub n is going to be equal to table. And I want to go from the value of n from 1 to length. Actually, I'm going to do my big N divided by 2. That's my number of harmonics. So I should have some 4 values right there. Excellent. There's that. B sub n is going to be the same exact thing, but now I'm just going to do my sign. Let's just make sure that I've gotten all these kind of parameters right. Yep, looks okay. So now I also know that my b sub 0 is going to be equal to 0, and I know my a sub 0 is just going to be here. But my cosine, actually, it's just going to be this, except we're not going to have, because cosine of 0 is 1, right there. And I know that my a sub naught over 2 should be equal to my, basically, my data, actually my total of data divided by big N. That's good. Excellent. So you can kind of look that up later if you haven't remembered that. So we are good to go now. So I can insert that into my harmonics, but it's asking me to plot the frequency spectrum and dominant frequency. So really, I just need to figure out now my C sub n. It's going to be equal to table square root of a sub n I squared plus b sub n I squared square root, going from I from 1 to length a sub n. And then that's the value right there. So again, basically just these square root summing, et cetera, et cetera. And then now I'm going to go from my f's, not my f sub s, my delta f's. So my freaks, I do table from I times delta f from I goes from 1 to length of a sub n. So I'm going to transpose that, and let's go ahead and transpose freaks with Cn. There we go. I'm going to list plot that. And we'll see that my dominant frequency here is actually my maximum frequency. So, and again, my maximum frequency is equal to my, it's 5,000, that's equal to my F Nyquist. So everything's looking right in the world. So we know that our dominant frequency is also, let me go back to the practice exam. Our dominant frequency is also our Nyquist frequency as well. So that's it. So a last question that you might kind of encounter on this exam is the following. So I purchased this jackhammer. Manufacturer claimed that the maximum jackhammer speed would allow the jackhammer to hit the pavement every 10 seconds. So it's going to hit the pavement a delta t of equal to 10 microseconds, or every that's the kind of the time interval it's going to hit the pavement. So that's going to correspond to a frequency. Again, the maximum speed, i.e. the maximum frequency, so F max is going to be equal to 1 over 10 times 10 to the 6. Let's go ahead and figure out that value. 10 times 10 to the minus 6. 1 over. It'll be 100,000 hertz. From this fast setting, you could decrease the frequency the jackhammer contacts by increasing the time in intervals of 1 microsecond. Will it be signal aliasing or spectral leakage in this experiment? So if I now go from here to here, so to 11, actually let's do this numerically. So now, again, I'm going to have a higher frequency resolution to hit all these different frequencies. So I'm going to have at least this kind of, for the first couple, this 0.1 is going to be what I'm going to need to have. So I'm going to need a delta F. It appears to be 0.1 hertz. But let's see if we can even hit this. So will there be signal aliasing? So our rule for signal aliasing is my F sub s has to be greater than twice my F max. What is my F sub s in this problem? Well, let's go ahead and look at it. 10,000? Absolutely not. So there will be signal aliasing. Yes, that will occur. Spectral leakage? Again, if we could only, what is our big, our delta F is equal to what? Let's look at it here. In this problem, 1250? Absolutely. So we're going to have spectral leakage. We're going to have signal aliasing. That is a huge problem, essentially, in this experiment. Or yeah, exactly. We did not. Basically, we are not going to have. We're going to have signal aliasing and spectral leakage in this experiment. We really failed, as you kind of might expect, with only taking 8 data points. So now, will you encounter something on an exam like this? Possibly, but more likely, again, I'm going to give you a signal, either something like time like this, or I'll give you like 1, 2, 5, 18.43, 576, and ask you again, is there signal aliasing, is there spectral leakage? You could also be given, again, a signal, not a Fourier series, but a signal in time, so sine of 17 pi t plus cosine of 18.3, I don't know why I'm doing 18.3 a lot, pi t, et cetera, et cetera. These are in circular frequencies. Again, omega equals 2 pi f. You'll have to convert. And again, is there signal aliasing? Is there spectral leakage? You kind of know, again, that delta f has to hit every single frequency kind of listed here. So we need to first select an f sub s, then you use the relationship that delta f is equal to f sub s over n. So this is fixed. This you'll see from the signals that you're given, and then you just solve for m. So that's it. Good luck, and we'll get to example 3 next time. Thanks. Have a good one. Bye.